Hey, this is Pranav Kulkarni, and in this video, I'm going to give you a demo on Proxy Server, queues, and cache fluency. This is part of the Homework 3 DevOps class. Um, so, as part of this homework, I have basically two scripts. One is the main.js, which is basically an application server where we have extended most of the functionality that we did in the workshop, like there is a slash hello world endpoint. There is a set endpoint which is going to set a message in your redis database, and it will say this message will expire in 10 seconds, and it will actually expire in 10 seconds. We can quickly check that using the slash get endpoint. And then we have slash recent, which is going to tell you the most recent URLs. This will always return the top 5 URLs that the client is actually accessing on the app server. And we have slash upload, which will upload some images onto our app server, which uses Redis as a backend. So this is just a quick overview of the application server. In the application server, basically I have maintained two Redis caches. One is the URL cache and the other is the images cache. I have another script called proxy.js, and this proxy server actually acts as a load balancer as well as the proxy routing server also, which will route the requests to multiple servers in a round robin fashion, which ensures that the requests are uniformly distributed to all the available app servers. So in proxy.js, I have used HTTP proxy as the library to implement the proxying functionality. I have the endpoints like spawn, list servers, and destroy in the proxy load balancer part. Spawn is going to actually create a new server, and it will create a new server starting from port number 3001 and so on. The list servers will actually give you the list of servers that are currently available. Destroy will simply destroy one of the servers at random. And there is also just a slash endpoint which will tell you what this proxy API can do. And here in the HTTP create server, I have the actual proxying logic written, which will basically proxy to the server that's next available. And as you can see, it just proxies the incoming request to one of the available servers, and it comes from the Redis database. In Redis, I have used the rpop lpush mechanism to maintain the round robin fashion of the list of servers to be used for our next request. So let's go ahead and quickly start the proxy server first. Cool. So I have my proxy server listening at port 3000. Let's see what that can do. Cool. So we have the proxy server running. Because we don't have any application servers running at this point, we should actually spawn one of the application servers. So let's go ahead and spawn one application server. So as you can see, we have spawned a new server which is running on port 3001. We can access this server via proxy, which runs at port 8080. So let's go and do 8080, and there we go. So we have hello world, which is being returned from the application server defined here in main.js. Here, hello world, and this localhost 8080 is actually where your proxy is running, which can be seen here in proxy.js, which is listening to 8080, and it is relaying your request to one of the servers, and in this case we have just one server running, so that proves that the proxy is running correctly. um, in my load balancer or proxy, I'm actually going to check the servers that are running. So list of servers, you can see there's only one running on localhost and on port 3001. So let's go ahead and make some regular app server requests. Like, for example, let's try and set a key. So I have set that key, and now I'm going to check the message will expire in 10 seconds. So I've done a get, and I got this, the message will expire in 10 seconds. Now this is clearly more than 10 seconds. Let's try and refresh this, and there we go. So the message has been destroyed. So this actually completes the set and get demonstration. Cool. The next step which I want to probably do is like check my most recent URLs that are being accessed. So these are my most recent URLs. The first one, of course, being the recent, then get, and set we did, and this was, of course, our the index URL which returned hello world. So that's the recent demonstration. Cool. Let's say we actually go and spawn one more server now before we actually try out the other endpoints of the application server. So let's go ahead and spawn one more. So it spawned a new server on 3002. I'm going to refresh this, which will spawn another server, 3003 and 3004. So if I do this servers now, I have 4 application servers running, 3001 to 3004. Cool. And here, if you look in this in the proxy, so let's say you do a slash resend. So if you do a slash resend in the proxy, you will see that the proxy server actually sent the request to 3004 because the new server was introduced, and now we want to keep all the requests uniformly distributed. So let's actually go ahead and try some of the other endpoints of the application server and see how this is, how each server is used in a round robin fashion to ensure uniform distribution of requests. So I'm going to upload an image. Cool. So I'll do this, and as you can see, I'm running it against the proxy. Cool. So as you can see here, when I uploaded the image, the request was sent to server running on port 3003. And let's say I upload one more image. The next request was sent to 3002. And I'll upload one more image which got sent to 3001. So as you can see, the requests are now being routed in a round robin fashion. So if I actually hit /meow, which is actually going to bring up the image. Now let's see what server it actually hits. So I've got the image, which means the URL is working, and it was returned by the server running on port 3004. Let me run /meow again, and I've got the next image, which got routed to port, this is the server running on port 3003. If I do it again, it got routed to 3002. Um, cool. So now let me just run a slash recent again, which means, as you can see, the recent URLs, and this slash recent was actually submitted to 3001. So this basically ensures that all the requests are being routed uniformly to each of the servers in a round robin fashion. Cool. And then this is my Redis client here in between, just to see what all keys I have in my um, Redis. I have the servers, which basically is the list of servers that are currently running, and the URL cache is where my recent URLs are being stored. All right, so I think as part of the application server endpoints, I have covered almost everything. Now, the only part that is remaining is the destroy endpoint. Let's try and destroy a random server. So it removed the server running on port 3001 randomly. So if I do a slash list servers, it shows that there are only 3 servers running: 3002, 3003, and 3004. Cool. So if I try and do some of the previous endpoints, so let's say I upload morning, so it picked 3004, and if I do, let's say, Harry Potter, it picked 3003, and if I pick ice cream, it picked 3002. As you can see, 3001 has not been picked up. And also, if you can see in the database, that 3001 has been removed. So obviously the next URL that will be submitted to the proxy will eventually be related to the server running on port 3004. Let's go ahead and actually test it out. Cool, so I've got the image and it actually went to 3004. If I do once more and again, so 3003 and then 3002. So this ensures that the proxy is not actually relaying the requests to the deleted or the destroyed server. So this actually completes all the demonstrations. So I have shown the setkit, recent, upload, and meow, and spawn, destroy, and list servers, demonstrated proxy as well. So yeah, that completes the demo. Thank you very much for watching.